Imagine gazing up at the night sky and seeing a faint red dot transforming into a vibrant blue. This isn't science fiction, but a potential future for Mars. You see, Mars, our rusty red neighbor, is losing its atmosphere. This might not sound exciting at first, but it's a cosmic drama unfolding right before our eyes. Why should we care about the air on a planet millions of miles away? Because that thin Martian atmosphere holds clues to the planet's past, including the possibility of ancient life. It's like a history book written in the language of gases, but this book is fading page by page as the Martian atmosphere escapes into space. And what's more intriguing is that this atmospheric leakage intensifies when Mars is closest to the Sun in its elliptical orbit. To understand why this happens, we need to delve into the fascinating world of solar wind, magnetic fields, and the dance between a star and its planets. The Martian atmosphere, though thin compared to Earth's, is a fragile shield protecting the planet from the harsh realities of space. It's composed mainly of carbon dioxide, with a touch of nitrogen and argon. This wispy atmosphere traps some heat, preventing Mars from becoming an utterly frigid wasteland. But this thin veil is not what it used to be. Evidence suggests that Mars once had a much thicker atmosphere, perhaps even oceans of liquid water. So, where did it all go? The answer lies in the relentless escape of gases into space, a process accelerated when Mars gets cozy with the Sun. Imagine a balloon slowly deflating. That's similar to what's happening to Mars, but instead of a rubber membrane, it's gravity trying to hold on to its atmosphere. And the Sun, well, it's constantly trying to snatch away those atmospheric particles. The closer Mars gets to the Sun, the stronger this solar influence becomes, leading to a more rapid loss of its precious atmospheric gases. This cosmic interplay between Mars and the Sun is a key factor in understanding the red planet's evolution. The Sun isn't just a giant ball of burning gas, it's a raging inferno of charged particles constantly spewing outwards into space. This stream of particles is called the solar wind, and it carries with it the Sun's magnetic field. Now imagine this solar wind as a vast, invisible current flowing through space. When it encounters a planet like Mars, something fascinating happens. Mars has its own weak magnetic field, a pale shadow of Earth's protective bubble. As the solar wind collides with Mars's magnetic field, it creates a sort of cosmic tug-of-war. The Sun's magnetic field lines drape around Mars, forming a magneto-tail that stretches far behind the planet. This interaction between the solar wind and Mars' magnetic field is where the atmospheric escape drama unfolds. The closer Mars gets to the Sun, the stronger the solar wind's grip becomes, exacerbating the loss of its atmosphere. Picture a game of tug-of-war, but instead of two teams pulling on a rope, it's the Sun's gravity and the solar wind battling for control of Mars's atmosphere. The Sun's gravity wants to hold on to the Martian atmosphere, while the solar wind tries to rip it away. Now imagine that during this cosmic tug-of-war, someone keeps moving the rope closer to the team representing the solar wind. That's essentially what happens when Mars gets closer to the Sun in its orbit. The closer proximity means the solar wind's influence grows stronger, giving it an advantage in the tug-of-war for Mars's atmosphere. This is why Mars loses its atmosphere at a faster rate when it's closer to the Sun. It's like trying to hold onto a kite on a windy day. The closer you are to the source of the wind, the harder it is to keep the kite from being swept away. Section 5. When heat makes things escape. Imagine a pot of water simmering on a stove. As the water heats up, the molecules move faster and faster, some even escaping as steam. A similar principle applies to the Martian atmosphere, especially when it's closer to the Sun. The Sun's heat, even at Mars's distance, is enough to energize the molecules in its atmosphere. These energized molecules move faster, and some gain enough speed to break free from Mars's gravitational pull. Think of it like a rocket needing to reach a certain speed to escape Earth's gravity. The same applies to atmospheric gases, and the Sun's heat gives them that extra boost, especially when Mars is closer in its orbit. So the closer Mars gets to the Sun, the warmer its atmosphere becomes, and the more molecules gain enough energy to escape into space. This thermal escape is another key factor in the Martian atmosphere's ongoing disappearance. Section 6. Imagine a Martian beach ball. Imagine trying to play beach volleyball on Mars. You hit the ball, and it slowly floats away, barely affected by gravity. This is because Mars's gravity is much weaker than Earth's, about 38% as strong. This weak gravitational pull has a profound effect on Mars's ability to hold on to its atmosphere. Think of gravity as an invisible hand trying to keep the atmospheric gases from floating away. On Mars, this hand is much weaker than on Earth. Now imagine that the wind keeps picking up, making it even harder to keep the beach ball from flying away. That's similar to what happens when Mars is closer to the Sun. The increased solar wind and heat further weaken Mars's already tenuous grip on its atmosphere, allowing more gases to escape. It's like trying to hold on to a handful of sand. The weaker your grip, the more sand slips through your fingers. Section 7. A Tale of Two Atmospheres. The contrast between Earth and Mars's atmospheres highlights the dramatic effect of the Sun's influence. Earth, with its strong magnetic field and comfortable distance from the Sun, boasts a robust atmosphere that shields us from harmful radiation and allows life to thrive. Mars, on the other hand, tells a different story. Its weak magnetic field and elliptical orbit, which brings it significantly closer to the Sun at times, have led to a slow but steady atmospheric leak over billions of years. This tale of two atmospheres underscores the delicate balance of factors that determine a planet's habitability. It's a cosmic reminder that even seemingly small differences in distance, magnetic field strength, or atmospheric composition can have profound effects on a planet's evolution. The next time you gaze up at the night sky, consider the contrasting fates of Earth and Mars, two rocky planets shaped by the same star, but with vastly different stories to tell. Section 8. The Case of the Missing Water. The disappearance of Mars's atmosphere is intricately linked to another Martian mystery, the case of the missing water. Evidence suggests that Mars was once a much wetter place, with rivers, lakes, and possibly even oceans gracing its surface. So, where did all the water go? While some may be locked away as ice beneath the surface, a significant portion is thought to have been lost to space, carried away by the escaping atmosphere. Imagine a pot of water left to simmer for billions of years. Eventually, even a large pot will lose most of its water to evaporation. This is similar to what happened on Mars, but instead of evaporating into the air, the water molecules were lost to the vastness of space. The Sun's influence, through the solar wind and heat, played a crucial role in this process, accelerating the loss of both water and atmosphere from the red planet. Understanding this ancient water loss is key to unraveling the history of Mars and its potential for hosting life. Section 9. The Future of Mars Exploration. The ongoing escape of Mars's atmosphere has significant implications for future human missions to the red planet. A thin atmosphere means less protection from harmful radiation, and a greater challenge for landing and launching spacecraft. Imagine trying to land a parachute on a planet with barely any air to slow you down. That's one of the challenges engineers face when designing missions to Mars. However, understanding the dynamics of Mars's atmospheric escape can help us develop innovative solutions. For example, future missions might utilize the thin atmosphere to aerobrake, using friction to slow down spacecraft during descent. Moreover, studying the Martian atmosphere provides valuable insights for terraforming, the hypothetical process of transforming Mars into a more Earth-like planet. By understanding how Mars lost its atmosphere, we can explore ways to potentially replenish it, paving the way for future human settlements. Section 10. Unlocking the Secrets of the Red Planet. The study of Mars's atmosphere is not merely an academic exercise, it's a key to unlocking the secrets of the red planet and our place in the cosmos. By understanding how and why Mars lost its atmosphere, we gain insights into the evolution of planets, the dynamics of solar systems, and the conditions necessary for life. It's like piecing together a cosmic puzzle, with each atmospheric gas, each gust of solar wind, and each ancient riverbed providing a clue to the red planet's past and future. The ongoing exploration of Mars, with rovers traversing its surface and orbiters peering down from above, continues to reveal new information about its atmosphere and its history. As we delve deeper into the mysteries of Mars, we are essentially looking into a mirror, reflecting on the delicate balance of forces that have shaped our own planet and the countless others scattered throughout the universe. Section 11. Our Place in the Cosmic Dance. The story of Mars's atmospheric escape is a reminder that we are part of a dynamic and interconnected cosmos. The Sun, our life-giving star, also plays a role in shaping the destiny of planets, sometimes in dramatic ways. Imagine a cosmic dance, with the sun at the center and planets swirling around it, their atmospheres swaying to the rhythm of solar wind and gravity. This dance is a delicate balance, and even small changes can have profound consequences over eons. As we continue to explore our solar system and beyond, we will undoubtedly uncover more stories of planetary evolution, atmospheric intrigue, and the intricate interplay between stars and their celestial companions. The next time you gaze up at the night sky, consider the vastness of space, the countless stars with their own planetary systems, and the cosmic dance that connects us all. It's a humbling and awe-inspiring thought, reminding us of our place in the grand scheme of the universe.